Hello everyone, welcome to the Mathematics Fantastic series. In this particular session, we will study some basic concepts of trigonometry. Now, first of all, we start with the applications of trigonometry, where trigonometry is used. These are very few applications. There are varieties of applications where we make the use of trigonometry. So the first one, as we can see, to describe the sound and light waves. So when we want to describe the electromagnetic waves, so we use this sign. Then simple harmonic waves, whether they are the sound waves or light waves. So we when we want to describe the wave and study the basic concepts of physics like interference, diffraction, we need some types, we need to represent those waves. So they can be easily represented by using trigonometry. Then it is used in astronomy for navigation purpose, to find the path, in aviation, in calculus, integration, differentiation, then differential equations, and we can even measure the height very easily using the trigonometry. Then criminology, finding the criminals, investigation, then creating maps, as well as marine biology. So these are some of the very few applications where trigonometry is used. There are varieties of applications. Now we start with the basic identities, trigonometric identities. For that purpose, we draw a right angle triangle, as we have done here. We have a right angle triangle. So this is the right angle, this is the angle theta. This the side, the length of this side is x, this is y, this is z. So here, because this is theta, so a side which is opposite to that is actually y, so we call this side as opposite side, and this side z, it is adjacent, so we call it as the adjacent side is z. And this side x, it is opposite to the right angle, that is 90 degrees, so it is called the hypotenuse, and the angle is theta. So how do we define the sine of theta? So sine of theta is actually opposite upon hypotenuse. So opposite is y and hypotenuse is x, so it is y by x. Cos theta is adjacent upon hypotenuse, which is z upon x, so this is z upon x. Then tan theta is actually sine theta upon cos theta, which is, if you find this, actually opposite upon adjacent, so it is y by z. Similarly, for sine theta, we have 1 by sine theta is actually cosec theta. So we have sine theta, when we take 1 upon sine theta, we get cosec theta. Then sec theta is 1 by cos theta, cot theta is 1 by tan theta. So these are the 6 basic we can say identities of trigonometry. Then there are some basic formulas where these trigonometric identities are related, just like the first one where we use it. So this sine square theta plus cos square theta is 1. So whatever the value of theta will be, sine square theta plus cos square theta is always equal to 1. Then 1 plus cot square theta is cosec square theta, tan square theta plus 1 is sec square theta. And this sine alpha, if we have something identity like in this way, sine alpha plus beta, we can actually expand it, sine alpha cos beta plus cos alpha sine beta. And these are some of the very basic identities with respect to sine, cos, tan, which are of course were widely used to solve many problems. So these are the things. Now let us see one of the basic application of trigonometry, that is measuring the height of a tall structure. So we have a very tall structure, and we want to measure the height of this particular structure. So one thing is, it would be difficult to measure if we send someone to the top of this particular height, and that person just sends the rope, and this rope touches this ground, and then we can call that person down and then measure that the length of the rope. It is a tedious process. Now how this trigonometry can solve this problem easily to find the height of this tall structure. So what we see in this case is that it is easier for us to measure this particular height by using this basic identity of, that is, we know the tan theta. So if this angle is theta, so let us assume this person standing here has an instrument by which he can measure this angle theta, which makes with the top this height of this particular what it makes with this horizontal. So this is theta. So we have instruments by which we can measure this angle theta, and this x, which is the distance from the building, that tall structure, to that person, can also be easily measured. So this is x. Now if h, this we can see h is the height, then this tan theta is h upon x. Okay, so because tan theta is opposite upon adjacent, so we get opposite is 7h and adjacent is x. So now h is equal to x tan theta. Okay, so now x can be easily calculated. We have an instrument by which we can measure this theta, so we just need to find tan of that particular angle, so h can be easily calculated. So this is how we can measure the height. Okay, this is very small application. There are varieties of such applications. Now let us see one more application, that is measuring the angle of descent of an airplane. So airplane is flying a particular height and it has to land, so it will just it will contact that particular control tower. Okay, and it will tell its height. So how much, what should be the angle of descent? So it must be calculated that at what angle this airplane must descend so that it lands on this particular runway. So now this airplane, it knows its height. Okay, and this air traffic control, it knows at what distance this aircraft is from this particular air traffic control. So we know this d and we know this h. Okay, so how to calculate this? So you can see this theta. Okay, this is the angle, this is the theta angle by which the aircraft has to land. This is the angle of descent. So this theta is equal to this. We have d, we know h. So this, in this case, we know the opposite. Okay, and we know the hypotenuse, and sine theta is the angle which actually relates opposite with the hypotenuse. So sine theta is h upon d. So theta is sine inverse of h by d. So using this particular identity, the angle of descent can be easily calculated. Okay, this is one of the application. Okay, now here are some basic trigonometric functions with the values are given. Okay, like sine. First we have just given some standard values: 0, 30, 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Of course we can also convert them in radians, but for simplicity we have just taken it as a in terms of degrees. So sine 0 is 0, sine 30 is half, 45 is 1 by root 2, 60 is root 2 by 2, root 3 by 2, sine 90 is 1. Then cosine, that is cos 0 is 1, cos 30 is root 3 by 2, and so on, and cos 90 is 0, as you can see. Then tan 0 is 0, tan 30 is 1 by root 3, 45 is 1, 60 is root 3, and 90 is actually not, because it becomes infinity at that point. Okay, now the value of sine and cos can be anywhere between +1 and -1. Okay, so the maximum value sine theta can take is +1, and the minimum value it can take is -1. Similarly for cos also, the maximum value is +1 and minimum is -1. For tan theta, it can take any value from, with respect to the angle, changing angle, it can go from +∞ to -∞. Okay, so these are the things. Okay, now we can easily represent the sine wave by using we can easily represent it by using this. We can represent this electromagnetic wave by using this sine wave. This is a sine wave. Okay, this is a sine wave. Why this sine waves? We can see this it starts from here. Okay, this wave actually starts from here. At this particular point, we see that sine 0 is 0, and sine 90 becomes 1. So at this 90 it becomes +1, then 180 it becomes 0, and at sine 270 is -1. Okay, so it goes on repeating itself. So this sine is a simple harmonic function, so it repeats itself again and again. Okay, after a particular cycle. So this is a sine wave, because sine 0 is 0, 90 is 1. Now the wave in this case is a cosine wave. Why it is a cosine wave? Because cos of 0 is 1. Okay, this is a cosine wave, so cos of 0 is 1. Okay, and cos 90 is 0, cos 180 is -1, cos 270 is 0, and 360 is again +1. So this will go on repeating periodically. So this is how we represent the cosine wave. So that's all for this particular session. We just had a very brief session about the trigonometry. Okay, so there are varieties of application where we can use trigonometry. So thanks for watching.